Hello and welcome to the Fireside Chat with the Hugo brothers. This is the Fire and this is Zachary Hugo.
And this is Skylar Hugo.
All right, my first question for you is I've heard that the vaccine is novel, and what ways is it unique?
This is a novel vaccine for a novel virus. It is a unique vaccine because it uses this thing. It's a particle called mRNA, which stands for messenger RNA. So the normal production inside of a cell is going to be that the DNA gets read, it converts into mRNA, and this little messenger RNA will leave the nucleus of the cell to produce whatever the cell needs. And the instructions get read and turned into this coding that tells proteins that produces things what to make. And that is the mRNA. Now, the interesting thing about this is that mRNA gets read, and the ones that we are injecting is mRNA that gets read to produce the antigens, which is the binding sites for COVID, without ever actually injecting COVID-19 into a person. So effectively, we are injecting the code that creates the outer identifiers of COVID virus particles without actually injecting COVID at all.
The virus. Okay. Would you say that the vaccine has been rushed at all?
Oh, sure. It's been rushed. There's been immense pressure on the scientists. But that doesn't mean it wasn't careful. No steps were cut out. We didn't skip anything here. In fact, Congress specifically decided not to allow for the FDA to skip any steps. Basically, the plan was if we do everything the same way we always do, we won't lose public respect for the process. Basically, no one's going to feel like it's
Avoid
been
the loss of support then.
absolutely,
Right. Okay.
absolutely. So it's been rushed, but it's still reasonable.
Right. Okay, rushed with due process.
Exactly.
I've seen a couple of inflammatory reporting articles and such about the adverse effects, mostly names actually. Should I be worried at all?
The answer is you shouldn't be any more worried than you would be about anything else. The FDA follows rigorous procedures to identify drugs and vaccines that should and should not be promoted. And at the end of the day, the adverse side effect reporting is as it always is. Basically, there's a trial procedure for how clinical trials must go on. There's typically 3 or 4 phases, and they include animal trials, human trials, trials that are designed specifically for safety, specifically for the efficacy of proving that the drug does what it's supposed to do. At the end of the day, you shouldn't be worried about this for any particular reason.
Okay. Coming with that, there are a couple of other myths that I'd like you to kind of debunk there. The first one being Bell's palsy. There's something to one of the released studies about some of the people who were on trial for the vaccine actually developing Bell's palsy, allegedly as a result of the vaccine.
Right. So a lot of the inflammatory reporting has been really misleading about this. One thing you need to know is that during a clinical study, all adverse effects that are experienced by any of the patients of the clinical study legally have to be reported.
So if I stub my toe during a study,
It could show up in a presentation later.
Okay, yeah.
And so the reason why I'm saying this is because what happened in this study is 4 patients out of the 22,000 that were on the vaccination arm of the study, because you've got the 2 arms of the study, you have the control and you have the experimental arms. So totaling 44,000. Of the 22,000 people that were in the vaccination side, 4 developed Bell's palsy after the vaccination, after they were injected with the mRNA. And obviously that means that it has to be reported. Are we worried about that? Sure, that's something that we need to look into. And the FDA has said that as we roll out the vaccine, we will be following up in studying that and collecting more data. But 4 out of 22,000 was not statistically significant to prove any kind of causality. There's no evidence for a causal link between the vaccine and Bell's palsy, because this wasn't any higher than background amounts of what the general public faces from the random development of Bell's palsy.
So it's within reasonable margin of error for regular individuals.
Right. It is statistically insignificant at this time, and we're going to continue to monitor it to make sure that if anything changes, that we know about it.
Okay, yeah.
And at the same point, a lot of the reporting has been overhyping it because Bell's palsy itself is unlikely to be permanent. I mean, one of the 4 patients who suffered it in this experiment only had it for 3 days and it went away on its own. Most people suffer for less than 6 months from Bell's palsy, which is completely non-fatal, which I would encourage you to compare to COVID, which is fatal, frequently.
Potentially fatal. Okay.
Right.
One of the other things I've seen a lot of people fear-mongering and complaining about is DNA editing. They're afraid that the vaccine will somehow permanently alter some part of them and cause them adverse effects later on that we may not be aware of presently, even in current trials.
Right. I think a lot of people see the word RNA or the letters RNA and they know RNA is something biological and they know DNA and so they're thinking, oh, well, maybe the mRNA is going to mutate me in some way or cause my genes to be edited. That's not what's going on here. It would be very unlikely, nigh impossible, for the mRNA that's being injected to actually get into your cell's nucleus. Like each of your cells have a nucleus, most of them. Some don't. It's blood. But most of your cells have a nucleus, and that's what we want is for the cells to be developing the antigens so that your memory B cells are then taught how to defend themselves against the virus when it comes to you. But it's unlikely, nigh impossible, that the mRNA that is injected would get into your nucleus at all, much less make any changes to your DNA. That's just not what's going to be happening. mRNA comes out of the nucleus, it doesn't usually go in.
Okay. Okay. And another one of the fears, and I think you kind of touched on this a little bit earlier, is will the vaccine give me COVID?
Yeah, for some reason people have this idea that when they get vaccinated for something, they're going to catch it. You know, my grandma, I think you knew this about her, used to say, oh, well, she never got the flu shot because the flu shot gives her the flu. That might have been true at the time because she lived, 80 years ago.
Right.
But these days, and this vaccine in particular, doesn't use the actual virus. The pathogen isn't being injected here. We're injecting a laboratory-developed molecule that creates the antigen so that your antibodies can be taught to bind to it. And you're never going to catch COVID from the vaccine. So
the virus is not in the vaccine?
Not at all.
Not even there?
Not at all.
Okay. Let's talk a little bit about mortality then.
Sure.
Historically, what are the leading causes of death?
So historically, the leading causes of death in the United States for the last 40 years has been cancer, referred to as malignant neoplasms, and heart disease. And in fact, this is our first visual aid of the night. Here is an image. This is from Whiskers, which is the CDC's reporting method for injury and mortality statistics. And this, as you can see in the upper right-hand side, it's all of the data for the last 20 years, from 1999 to 2018. And as you can see, heart disease made up almost, more than a quarter of all fatalities, and 22% were from malignant neoplasms, which I remind you is cancer. So my point here being, those are the 2 highest causes of death, and you have to really come down low on this list to find any kind of transmissible disease as a high cause of death. It's not until you get influenza.
See, the flu looks like, what is that, the 6th off?
It's 8th, I believe. 1, 2, 3, 4, 5, 6, 7, 8th. It's 8th. So yes, it is one of the top 10 leading causes of death, but it is in 8th place. And that's influenza and pneumonia. And so why am I showing you this? Well, basically, at the end of the day, 2020 has been a wild year, and pandemics are outliers. They create causes of death that are very unusual, that we've never seen before. Um, Last year, COVID didn't exist. And this year, I'm going to make the claim that COVID will be the third leading cause of death in the United States for this year. And to support that claim, um, I am going to pull up just the most recent data. So this was causes of death um, from 2018. So this is the most recent data that we have from the same reporting database from the CDC called Whiskers. And if you look at the numbers here, uh, below heart disease and malignant neoplasms, you have unintentional injury, and that's going to count for things like uh, car accidents and other causes of death. But really, what I'm getting at is that COVID's going to fit between these things. It's going to fit between heart disease and malignant neoplasms and unintentional injury. At the end of the day, we're going to have that 300,000 deaths that we've recorded as of today.
Right now. Yeah.
Right now, that's going to be right below malignant neoplasms and above whatever else is below it. And nothing's going to be close. Like, see how big of a gap there is between all of the things that are kind of close, above 5%, and then all of a sudden it jumps to 20%?
Right.
There's no
It's,
way.
it's a wide gap to bridge there. Yes. Yeah.
Right. And there's no way that it's going to get more fatalities than cancer. It's not going to jump to number 2. So I'm secure in my bet that it's going to be the third leading cause of death. Yes.
All right. And this is one that we've mentioned it a couple of times. How many people have died so far in 2020 as a result of COVID-19 related illness?
Right. So a lot of people had issues with reporting measures, but pretty much no matter where you look, if you look at the most conservative estimates or the most liberal estimates, you're going to find the answer is about 300,000. Right now, Johns Hopkins is reporting that number, and they're considered one of the most reliable sources. They're even slow to report. They're usually a day or two behind, and they're most consistent. And 300,000 is where we're at. Obviously, no one died of COVID for the first 2 months of the year, and we have another 2-3 weeks left of this year. So we could reach, a couple thousand more deaths before the end of 2020.
And we're talking just in the United States, correct?
Yes, this is just in the United States, and also the other boundary on this is, or one thing to consider, take into account here, is no other cause of death stopped. Cancer and heart disease did not stop in 2020 just because we have a pandemic. You can make the argument that accidental injury is going to be lower because less people were driving this year, but not so substantially to make up for how many people died from the disease. And so at the end of the day, these are all additional deaths on top of everything else that's normal.
Okay.
In the United States alone. Yeah.
Let's talk a little bit about how mortality is actually calculated, both of COVID and any other related illnesses or anything like that.
So the first thing that you're going to do when you're taking a data set is you get that raw number of how many people died. And then the second thing you're going to do is divide it by something to construct a ratio. And frequently people will divide the number of people who died by the total population. This is a somewhat misleading number. It's referred to as the cause-specific crude mortality ratio. And really, that's long statistics language for this is what caused the death out of how many total people there are. And unless you compare apples to apples and really think about those numbers for different causes of death, that's a really abstract number that's hard to ground yourself around and really conceptualize and internalize that number, because it's going to be a big number or a very, very small number.
Right.
And it's not going to make sense. So what epidemiologists and public health officials will do is instead they use what's called a observed case fatality ratio. And this is much more helpful when you're thinking about what are my odds if I am to get the illness, what are my odds of dying? And the way that that's constructed is you take the number of people who have died of the disease, divide it by the total number of people who have tested positive for the disease, and then you multiply it by 100. And the reason being, you want to convert it from a ratio to a percent.
Right.
Right.
Okay.
And that's mathematically how you do it. Percent means per 100.
Per 100. Out of,
Right,
yes.
out of 100. So here's our third visual aid. Basically, this is that math. It's just number of deaths over number of all cases multiplied by 100, and that's the case fatality rate. The reason that this doesn't say observed case fatality rate is because this is a more theoretical, like,
Assuming everyone has it.
assuming that everyone that we know everyone who does have it. This would be
Okay.
this would be like if you turned purple when you had it, easy to identify.
Right.
Obviously, with COVID, it's really hard because not all cases are observed. Many people are asymptomatic, and that changes
Right.
things.
Right.
But overall, now that we have good testing, even people who are asymptomatic can be tested as long as we have sufficient testing supplies.
Mhm.
Yes.
And there are a lot of things going around to assist people in tracking whether or not they should get tested as well.
Right, and unfortunately, not enough. There needs to be more of an initiative to have contact tracing and more testing initiatives. Our modeling suggests that we need less than 10% of the tests that we administer to come back positive, because that tells us that we're catching most of the cases.
Okay. Yeah.
If you look now, it depends on the state, but most of the states in the United States are not testing enough. Most are coming back somewhere in the realm of 10 to 20% positive, meaning that they're just not putting out enough cases, or sorry, not putting out enough tests.
to catch all of the cases. Right.
Right.
Okay.
Right.
So I understand that you may have a fairly personal reason to be so invested in specifically COVID. And I understand that you're taking on a new job here. What would that be?
Yeah, so I have applied and gotten hired for a new job. I'm going to be a COVID tester in hospitals, working night shift around the valley in different hospitals. And so I'm going to be up front and center. I'm going to be a frontline worker in a healthcare role, which is very exciting for me, but also very scary. And so I want people to be staying home. I want people to be masking. And most importantly, I want people to get the vaccine.
Right.
Once the vaccine is available to you, you should get it unless you have serious, health conditions that are complicating this. But generally speaking, most people can get this vaccine, and they should. And when we can't vaccinate, or when it's not available to us yet, we should be masking every time we're outside, every time we're in public, keeping a distance whenever possible. They say 6 feet, make it 8 if you can. You want to be far away from people in public, and you only want to be going on essential trips. That means not visiting family for the holidays. That means not going to unnecessary shopping trips, and certainly not eating in restaurants and going out when it's just strictly not essential for your life. Realistically, we should be quarantining ourselves whenever possible. Yeah.
All right.
I think that's all we've got.
That's everything I've got.
Have a good night.